Hello, friends. Welcome to another session on 8051 microcontroller programming. And today we will be discussing on addressing modes. So, addressing modes. Basically, an addressing mode are the methods by which we will be accessing the memory locations. Means these are the different methods how we can access the data from the memory. So five basic addressing modes include first one immediate addressing mode, then we have a direct addressing mode, then we have a register addressing mode, then fourth one is register indirect addressing mode, and the last one is index addressing mode. These are the five basic addressing modes. So first one, so immediate addressing mode. So in this mode, the data which we need for the operation is immediately available in the instruction itself. The instruction itself contains the data. Here you can see one example. I have given move a comma hash 99d. Move, we have used the instruction so that it is very easy to understand. So first, if you see move a comma hash 99d, that means d indicates it's a decimal value. So this 99 value is directly moved to register A. Register A is accumulator. And remember, when we want to transfer the data to an register, we need to use hash symbol. This hash prefix indicates that this is a data. So the same value will be loaded to accumulator. Okay. So here we can see another example. Move a comma hash 99h. So here it was D, here it is H. So that means this is a hexadecimal number. Here it was a decimal number, here it is a hexadecimal number. The suffix what we add indicate what is the base number system we are using. However, the syntax is still remains the same, that is a comma hash 99. And then we have another example wherein we are again transferring the hexadecimal number, but the hexadecimal number what we are using in this instruction are AF. So now if I want to transfer this AF to the accumulator, then I have to prefix 0 to this also. That's because if the value is starting directly our numerical values, what we call in the decimal numericals, then we don't have to add 0 to the beginning. But when we have a alphabet indicating a number, that is as in case of hexadecimal number system, from A to F number, when we have the number starting from this alphabets, then we need to prefix this 0 to indicate this should be considered as a numerical value. And if you observe in all three instructions, we have a instruction, and then we have a destination, and then we have a source. This is a standard syntax. So always we start with a mnemonic, that is whatever the instruction we want to write. Then first operand what we have is a destination, and the second operand is source. Here we can see the pictorial representation of the same, wherein we can see that the value 99 is moved to accumulator. Okay. So this is very simple, wherein the data is available in the instruction itself, and we are moving that to one of the register. Here we can use any register. So we can use GPRs, we can use A, we can use B, we can use DPTR. Like that, we can use any register here. Okay, in immediate addressing mode. Wherever we have a restrictions, there I will be mentioning separately how the restriction is put on a particular registers. Otherwise, by default, we will be using all the registers in the instruction. Okay. So next addressing mode is register addressing mode. In register addressing mode, we are trying to transfer the data from one register to another register. That means the required data is available in one of the register, and we want to read that value. In the previous, the directly value was available in the instruction, but here the value itself is not available. Rather, we are mentioning a name of a register which contains the value what we need. So if you see the example, move a comma r5, move a comma r5, that means what? As I said, mnemonic, destination, source. So r5 is a source, a is a destination. The content of r5 is transferred to a. Okay, then we can see another example wherein r1 comma a, because all the instructions have given a as a destination. So just to demonstrate that a can be a source also. So r1 comma a, this is also a valid instruction. Then we have another instruction, simple addition, wherein a and r5 will be added. The values in the a and value in the r5 both will be added, and the result will be stored in a itself. Now, one thing we have to remember here, we are transferring the value from r5 to a or a to r1, that is from a to gpr or gpr to a. That is because we cannot directly transfer the value between two GPRs. I cannot write an instruction move R1 comma R5. That would be a invalid instruction. Remember, we cannot transfer data directly from one GPR to another GPR. Then the next addressing mode we have is direct addressing mode. In this addressing mode, instead of giving a value, we are directly giving a address of a memory location from where the data has to be read. So if you see, move a comma 47h, one thing you have to observe here, in previous instructions, that is in the immediate addressing mode, when we discussed the number what is given here, before that there was a hash symbol. Now here there is no hash symbol. So remember, if the hash is given, then the date is considered as a data and the value itself is moved to destination. But here, as we don't have that hash symbol, so this 47 is considered as a address of a memory location. Now what happens? It will go to the address in the memory location, that is in the data memory, that the RAM what we have, that is the 128 bytes in there, and from whatever the content is there in that memory location, that is 47h, that content is moved to accumulator, not the 47 itself. If I mention a hash symbol here, then 47 itself would have transferred to accumulator. But now what happens? Instead of directly 47, I am telling the microcontroller that go to the memory location having a address 47h, then read the content of that memory location and copy that to accumulator. So that is how it works. Similarly, we can use a address as a destination also, that is to write the memory location. Here the content of accumulator is written to that memory location. In the first instruction, we are reading the value from the memory location. In the second instruction, we are writing the data to the memory location. Remember, all both the operations are on the data memory. Okay, move instruction works on the data memory. Okay, this is direct addressing mode. So next is indirect addressing mode. In this indirect addressing mode, the data required is available in the memory location of the address stored in one of the registers. So indirect addressing mode provides a powerful addressing capability. Actually, this is very helpful in most of the operations, especially when we do a looping and all those things, we'll be using these instructions. Let's see how this works. Again, I'm using a move instruction a comma r naught, but here r naught is prefixed with a at symbol. That means, now what I'm telling, the content of r naught is an address of a memory location. If I don't give this at symbol, what happens? The content of r naught is taken as a data, and that data is directly copied to accumulator. But now, as I'm mentioning at r naught, that means the content of R0 should be considered as an address, then go to that address, then read the data from that memory location, and then content of that memory location is copied to accumulator. So here, instead of directly copying the content of R0, we are telling R0 is having an address, and microcontroller should read the data from that memory location in the data memory again, and then copy that to accumulator. This is indirect addressing mode. And here in 8051, this addressing mode, that is indirect addressing mode, is supported only by R0 and R1 register among GPRs. I repeat, this addressing mode, that is indirect addressing mode, is supported only by R0 and R1 among GPRs in general purpose register. Okay, fine. So then we go for the next addressing mode, that is indexed addressing mode. This addressing mode is a little bit complex compared to other, because we have two addresses coming in this particular type of addressing mode. Here we will have something called as a base and offset addresses. In simple words, if I have a block of memory, base is the starting address of the block, and offset is how many bytes from that starting address I have to go. That is offset in simple words. So here, for example, we can use PC and DPTR. So they are applicable with this index addressing mode. Okay. So here we'll be taking an example of code memory access. As I told, we have a separate instructions to access different memory locations, right? So here I am giving an example to access the code memory. Okay, the move c indicates it is a code memory instruction. If I write only move, it is data memory. If I write move c, it is a code memory instruction. Move c a, again it is a destination, comma, at a plus dptr. That means what? First, the register a contains the base address, and the dptr register, that is data pointer, will contain the offset address. So if the a is containing say value 50 and dptr is having 15 or 20, then 50 is considered as a base address. First I will go to that address. From there I will jump 20 bytes, which is the content of dptr. Then I will access from that location. Okay. So in simple words, just understand, we will have two addresses here, base and offset. Offset address is added to the base address, then we'll get a actual address. From that address, whatever the memory is there, we'll go to that memory location, then we will read the content of that memory location, and then we'll transfer that to accumulator. Only extra thing is this addition of the offset. Okay, fine. Then here we can see the same pictorial representation wherein we have a base address. Say for example, accumulator contains this address, then offset, how much is the distance we have to travel from this base address. We'll go to offset address, and then we will get the actual physical address to access. Then content of this will be read for the further operation, that is for the read or write operation, whatever we want to perform depending on instruction what we are using. Okay, that's it for this video. Some more derived addressing modes are there, which we will be discussing in the next video. Okay, thank you. Have a good day.